Sure. So, hi everyone. This is Ankur from Farmonaut. Just to give a brief introduction about us. So, we started back in 2018. We had a vision to democratize the use of remote sensing data in the field of agriculture. So, I assume that not everyone must be knowing about what remote sensing and satellite applications are. So, I'll just try to very quickly explain the problem statement and then I'll move into what all we do. And just let me share my screen as well so that I can take you through the presentation as well. So I hope I'm able to I'm given the host.
Yeah, you
Uh,
should be able to. I let all permissions for it. So,
I think my screen should be visible to you now.
yes, it is.
Perfect, perfect. So in agriculture, there are a lot of challenges which a farmer faces. If in case if there is a maybe a pest, a disease, or a weed, or maybe some nutrition is lacking in the farm, or probably if in case the farm requires some irrigation. So usually what happens is you go visit the farm, do some visual inspection, and based upon how the farm is looking like at that point of time, you then decide what action should be taken. So this is how in reality how these actions are taken on the ground. However, there are a lot of challenges behind the same. For example, if in case there's any pest, disease, or weed on the farm, so usually the advent of a new a pest or a disease and its symptoms being visible to the human eye, there are a lot of it sometimes has maybe a gap of few days because the leaves turning yellow or brown or any other symptoms, unless you don't see those symptoms you will not be able to diagnose it. So what happens is by the time you observe all these problems on your farm, it might be too late for you to take any actions because uh, the symptom is already spread all across the farm. Now the what happens is these symptoms they start influencing various plant characteristics like the photosynthetic level must have maybe have started to decline, maybe the chlorophyll content may have affected. And these minor things we cannot see using human eyes, like unless the symptoms unless they are directly visible to the eyes. But once these changes happen on the farm, on the leaves of the plants, these things behave differently at different light wavelengths. The absorption and reflection is different at, let's say, a red wavelength and NIR wavelength and other wavelengths. And these things can be sensed by, for example, drones, for example, satellites. So what this remote sensing and satellites they do, they sense various how the plants are behaving at every location at different light wavelengths, and based upon what light characteristics the satellite sensors are sensing, then accordingly we can deduce what part of the farm requires maybe irrigation, what of the part of the farm maybe has some crop health issues, what of the farm part of the farm maybe requires some nutrition. So using these scientific the way the plant behaves at different light wavelengths, we can use and leverage that data to actually take meaningful action on the ground. And this is a very advantageous thing. So now let me move to actually uh, so yeah, if in case, see, if you don't use this knowledge, what you will do is you will based upon your knowledge of how the what general knowledge of maybe the what the crop was there on the farm, how many months have gone by, and based upon all these knowledges, you will try to take action on the farm. But because of it, you may end up giving inefficient irrigation, probably more irrigation to your farm, more than that it required at that point of time. Similarly, if you don't know which part of the farm require more nutrition and which part of the farm maybe has more spread of pest or disease, you might be spreading your uh, fertilizers, insecticides, pesticides, herbicides, organic fertilizers uniformly all across the farm, and that will also end up uh, like unnecessarily extra, like using your resources extra. You can actually minimize that extra misuse of your resources. Similarly, if you don't know where the problem exists, you might end up sending people to inspect the entire farm. So all these challenges like these can be mitigated using remote sensing and satellite data. So it's not like that satellite data did not exist before we entered the market. It has been there for more than 2 decades. But the problem has been that this is not accessible easily to everyone. It was sort of a technology of elite. Like it's not something that can be used by everyone. So this is where we come into picture. What we have done is we have made this system so simple, so easy to use, so affordable that any farmer, be it from Canada, from US, from Africa, or from maybe Southeast Asian countries, anyone and everyone of any farm size, they can use this data. So this is what we have done is we have made it so simple and easy to consume and so affordable that now it can be used by anyone. And so that's where we come into picture. So we started in 2018 and we made this satellite system available to our users by via APIs, web app, mobile application, Android, iOS. In low-income countries, we also provide this satellite data via WhatsApp because in a lot of low-income countries, not every farmer is very much tech savvy and they don't understand how to use and operate new applications, but definitely they know how to operate WhatsApp. So we have made this data available via WhatsApp as well. I'll move into what data we provide and actually a lot of case studies and what scale Farmonaut is actually now operating at. So I'll move into that part. So how it is done? Like simply, you just have to first of all, for being able to provide you satellite data and like decision on the ground, we just need a few information from you. You just need to input the farm boundary coordinates. Basically, how does the like what are the boundary points of your farm? We just need that information. We just need information about what crop is there on the farm and on what month and date you actually planted that crop on the farm. We just need only these two, three informations from you. And after that, it is a system which generates these insights. So the satellites that we are currently using, they scan every location on the on the world every 3 to 5 days. So let's say today is March 20th. So if in case a satellite visit has occurred today, so another visit will occur on 24th, then 29th. So every 4 or 5 days, you'll receive a new set of results. Like at this present point of time, how does the crop look like? Do we see any issues in the farm? If in case there are any issues in the farm, what are the potential remedies? And also a proper irrigation chart and multiple things we provide. We'll discuss it later. So as simple as that, just give us the coordinates, give us the name of the crop, when did you sow that crop, and you're good to go. As simple as that. And you can be a small farmer, like just to give you a scale, like in Africa, we deal with a lot of farms which are as small as half an acre, like almost 2,000 square meters, which is a very small farm. But despite that farm being very small, we are able to provide the insights to them. And in contrast, like in Australia, for example, we have farms as big as like 1,000 hectares. So regardless of what farm size you have, you can still get benefits from this like this data. I'll cover this tree counting and solar organic and all these things in the next ongoing slides. So yeah, I assume that not many of you might be aware about all these uh, various like satellite indices that are actually used to generate these crop health, irrigation, and soil analysis, all these insights. So just give you a brief context. There's something called satellite indices. Like when you combine different the like light wavelengths set from different wavelengths, you can actually create some major insights. For example, in case of crop health, we generate NDVI, EVI, SAVI, and NDRE. I'll just like very quickly go through them. Like these are like a combination of light wavelengths at different like spectrum. Like for example, NDVI, it's a normalized difference vegetation index, which is a normalized difference of red band and an IR band light wavelengths, and how this particular farm is actually uh, absorbing and reflecting light at those wavelengths, and then accordingly it just lets us know like which all places probably have some problem. And we have made the interpretation so easy. Like in a lot of farmers, they perceive color pretty well. Like if you tell them that there's some hotspot, and if you color code that in red, because farmers they know that red is the color of danger and green is like everything is good. So we color code in those simple color notations so that they know which part of the farm they need to focus more upon. For example, this is a probably a portion of your farm where light, like we have color coded this part as slightly like in the lower ranges of health. For example, this is yellow. So that means ki, except every other part of the farm which is growing okay, probably this is some portion where some action needs to be taken. So when you know what part of the farm you are supposed to take care of more, you just need to visit this part first and understand what can be the root cause, and then take the actions accordingly. If you did not have that information, you would probably end up visiting the entire farm, and that will take a lot of time. You will take more resources, and it might end up like you may end up taking too much time and like maybe end up taking wrong diagnosis. So that's what these indices help us in. I'll try to be a little bit not that much scientific, but like these indices help a lot in actually deriving what to do on the farm. So we generate almost 18 such indices. EVI is Enhanced Vegetation Index, SAVI is Soil Adjusted Vegetation Index, NDRA is Normalized Difference Radius Data. Another important thing is like we don't bombard and like impose the farmers to know all these indices because it's not necessary. What we do is we convert that raw information to into a language which farmers can understand, because farmers, they don't bother about like what wavelengths are we using, what indices are we generating. It doesn't matter to them. They just simply want to know, like, given the current satellite visit, what should be their irrigation schedule for the next 7 days on a daily basis. What are the current pest, disease, and weeds on the farm, and if there are any pest and disease and weeds, then what are their organic and chemical remedies. They also want to know, like, given the current situation, what is the expected value of multiple like major macronutrients like nitrogen, phosphorus, potassium, sulfur, zinc, SOC, pH value, and if in case there is any deficit, so what actions should they be taking on the ground in terms of, if in case they're doing organic farming, what should be their organic solutions? If in case they're doing some like chemical farming, what should be their chemical based solutions? And given all these insights, if in case they don't change anything, what is the expected yield that they're expected to achieve? We also provide those. So they also need to know all these informations. So even though on the background, it's all these scientific indices, 18 different multiple satellite parameters that are getting used to derive the data, but at the end of the day, the farmers, they just want this information to be given to them in a simple way. They don't want to overcomplicate the things. So that's what we do. I'll just get into that part. Another important thing is like satellites being in space, and there will always be some chances of like when the satellite is going on top of your farm, it might find some cloud on like on when it tried to sense your farm. So clouds, they play a very big role. Maybe it affects actually the sensing of activity on your farm for any normal multispectral satellites. So it becomes a challenge when you are living in a location where cloudy weather is something which is a which is prevalent for a larger part of the calendar year. So what we have done is we have integrated micrometer radar satellites. So radar satellites, like those micrometer wavelengths, they have this capability to actually penetrate the dense cloud and actually see what is happening on the farm. So we use like radar data to actually ensure that even if in case uh, we sense that there was cloud on top of the farm when the satellite visited, we can use radar sensors to at least let the farmer know what it is their current crop health and soil moisture data. So by integrating multiple like data from multiple types of satellites, we are able to ensure that the farmers are getting some information from us, even if in case the weather was not favorable to them, so like to the satellite. So that's what we have done is like no matter of no matter whether the cloud weather was cloudy or not good enough for us to sense any data, we still have some information to give to the farmer. So that's the best part. Coming to yeah, so as mentioned again, like this data can be used for a lot of things. Like you can use it for crop health monitoring. You can do it for like plantation management, land use, land classification, Crop area and yield estimation, I'll get into that part as well, because not apart from just uh, sensing what is happening on a single patch of farmland, we can actually use this data to actually understand and identify in a larger geography how many of the what how much percentage of this particular area is growing probably wheat, probably sugar beet, maybe wheat or paddy, rice. So we can use this satellite data to actually do some crop identification as well. We can also use this data to help understand how many trees are there inside the farm. And if in case you are doing some plantation, long multi-year plantation, then if you see like compared to last year to this year, have you seen that any trees got uprooted? So the use cases are many depending upon what kind of industry you're coming from, but every such industry can be catered via this remote sensing data. Yeah, now coming to what actually farmer receives. So I've given you all the scientific insights, how the system, what are the scientific note like literature behind the same. Now I'll let you know what actually the farmer receives. So as I mentioned, farmers, they don't bother about like what wavelengths are we using, what indices are we using, all that. They just need a plain and simple like advisory chart. Like okay, so today has a satellite has been a satellite visit. So according to the data that we have of the farm, like for us, we have so much information about every farm. Like we know that what crop is there, we know what month and date that particular crop was sown, we know what at what location, latitude and longitude this farm is actually at. We know via various satellite indices that how the crop health and irrigation and evapotranspiration and soil moisture and water stress, all these things have changed throughout the course of its like cultivation cycle. And we also know that for this particular farm, how the weather has changed so far, like how the temperature has changed, how the humidity has changed, how the precipitation values have changed, how the do we see have we seen any rainfall in the previous like days. We also know that how the weather is going to change for the next 7 days. We can predict use weather forecasting information. So considering that we have so much information about the farm, we can actually come up with a lot of insights about that farm with much accuracy. So that's what we're doing here right now. Like once the satellite visit has happened on the farm, we let the farmer know for the next 7 days what should be the irrigation schedule for every day, considering what is the current water stress values, evapotranspiration values, soil moisture values, what is the rainfall expected on that specific day, what was the crop on what part of the harvest cycle this particular crop has reached. So, and what location this particular crop is in. So, considering all these informations, we let the farmer know what should be their irrigation schedule. Similarly, like if in case the system has sensed that some crop health indices have dramatically changed, or probably there has been a sudden spike in temperature difference or humidity values or precipitation. So can those be correlated with the advent of a particular pest disease or a weed? So we use those informations to understand and let the farmer know like what are the expected pests or diseases or weeds and what are their probabilities and what are the organic and chemicals remedies. So we also let the farmer know about these informations. And one more important thing that we do is we also like if you click on this I button, you can actually do see actual proper reasoning behind about like how are we deriving these information. Similarly, for fertilizers also, we let the farmer know, like currently, what is the expected value of nitrogen, phosphorus, potassium, sulfur, and zinc. What were the expected values and what were the sensed values? What is the deficit difference between these two values? And to fulfill that deficit, what should be your solution? So actually, now the system is updated. Now you will get both organic and chemical solutions. So this is another important thing. We also have started providing like expected pH value, expected salinity on the farm, expected SOC value. So now the farmers are receiving this information, so many informations about it from us. Another important thing here is like not every farmer understands English because we are dealing with farmers from more than 40 countries, and like everyone like not everyone has like handholding of English. They understand their local languages. So the system is built in such a way that it caters to all languages. Like if you are probably from Indonesia or from Malaysia or from Africa or from Canada, for example. So it can be it is a multilingual system. Like you receive this data in the language which you prefer. So because of it, since the language is no bar, uh, it becomes easier for them to actually consume this data. So this is like pretty helpful for them. Uh, Now coming to the most important thing, like how much accurate this data is, because giving some information to the farmer and it being accurate, they are two separate things. We can come up with numbers if they don't match with ground reality. What is the like what was the entire like thing? We have to ensure that these numbers are as close to the near ground values. So that's what we have achieved. Like from the feedback that we have received from our business clients, from our farmers. So just to give you a context, we are catering to more than 200,000 farmers all across the world. We have 40 plus countries where these farmers exist. We have more than 10 million hectares of farmland that we have monitored so far. So we have a big scale of like usage. So based upon the work that we have done so far in the last 6.5 years, we have been able to maintain our accuracy beyond 90%. So that's what we are, and this accuracy level percentage is a survey that is that data that is given to us by our clients and farmers. It is the farmers who are reporting back to us that this is the data that we are giving to them. It's matching like to this much accuracy with the ground data. So that's the major thing here. Like since accuracy is not compromised by using remote sensing data, it becomes a more cheaper, viable alternative to soil testing labs, especially in the countries where soil testing labs are not pretty you can't like it's difficult to like accept their data because there are a lot of like mismanagement happening, and soil testing results are not from those labs are not actually pretty accurate. So that's the thing. And in terms of value addition, like uh, so far we have seen that farmers are able to save anywhere between 10 to 25% in total expenditure on farm inputs. We have seen that because you know where you have to go and do the survey, the farmers are able to reduce their survey time by at least 90%. And also because you know where the problem exists, and you know prior to the advent of the problem where that problem may arise, you are able to actually save around 10 to 35% in crop losses as well. Like whatever damages you are expected to have because of not being able to detect a problem in advance, you are able to save in crop losses as well. So that's the like these are all the benefits that the farmers receive. In terms of like carbon footprinting, definitely if you are uh, using inputs on your farm responsibly, you're not wasting water, you're not wasting fertilizers. Definitely, it's a good add-on for everyone, like for the farm, for the farmer, for the end user. Everyone is happy. So that's the important part. Uh, Now I'll move to, so I have just given you all the literature, like what's the scientifics behind all these things. Now I'll go to actual real case studies, like what works we have done so far and what have been their actually like feedback, and in what scenarios they have been using this system, and what are the like overall like benefits that have been received so far. So we are working with more than 50 companies worldwide. As mentioned, we have farmers present in 40 plus countries. We have 200,000 plus farmers who have benefited from this system, and we are monitoring more than 10 million hectares of farmland worldwide. So coming to one such example, so there's a company named Godrej Agrovet. You can Google about it. So they are working with us from year 2021, and they are in the plantation business. So they have more than 100,000 acres of plantation, which is currently under monitoring with us. They are around 34,000 farms. That's the number of farms that we are working with them with. So they had a problem statement like there are so many farms and they have like so much area to monitor, and it had become difficult for them to actually manage all these farms using just the feedback of the ground staff. So they had around uh, a team of 1,000 people who used to visit these farms and then let the team at their headquarters know that which of these farms require water, which of the farms require some crop health related, like pest disease or nutrition related actions, which of the farms had faced any uprooting of the trees, which of the farms have had like are expected to have lower yield. So these things they used to do via the ground staff, and because this ground staff was not a permanent team of this company, they were facing a lot of uh, like misrepresentation, like their feedback not being actually matching with ultimate final survey that happened. So this is where we have come into picture. What we have done for them is we have first of all used our application. So we have distributed our application to their ground team, and their ground team is actually using our application to geotag all their farms. First of all, like they go and visit the farms, they geotag the boundary coordinates, like what were the latitude, longitudes, the entire boundary, what and minimum information about the farmer, like the farmer name, farmer phone number, the farmer's land ID, code ID, all these things, and they are just creating that digital repository of all of their farms using our system. And once that digital repository is ready, what our system does is it scans through all of their farms via satellite data that I just showcased to you. And now, instead of visiting all of their 34,000 farms, if in the system filters out for them, like out of the 34,000 farms, maybe there are 3,000 farms at this present point of time which require irrigation. Maybe there are some 4,000 farms which require crop health intervention or fertilizers. So instead of now sending their team to the entire set of 34,000 farms, now they're focusing only on those farms which satellite has sensed to have some problem with. So this is a big value addition for them, because now they're able to save a lot of money in uh, in actually in actually because they don't need that much of human resource on the ground. They just need to and also they just don't need to blindly go, like allot some tasks to their ground team. They just need to know what is happening on the ground using satellite data that we provide, and then accordingly they just need to mobilize their team on the ground and just make them visit only those locations where something is wrong. So that's how they are using our system. It's one of the ways. Another way is like for them, it's very important to know for like on each and every farm how many trees are there. So what we do is we provide using high resolution satellite data. We'll let them know using our analysis, like for every farm how many trees are present, and because this plantation, this it has an average that in every hectare there will be around 140 to 145 trees. So if in case there are farms where this average is not maintained, they can just filter out those farms and they maybe contact the farmers directly and identify like why the number of trees is not uh, expected upon average, what is the issue, and ensure that if in case any replanting needs to be done, they help the farmer to actually do that replanting. So we help them identify the number of trees and then decide what next action should be taken on the ground. Similarly, we also let them know because they're in the plantation business in a specific geography. So they sometimes don't know where all they have not geotagged the same plantation. There might be a location in this geography where plantation exists, but they don't know. So what we do is using high resolution satellite data, we scan those geographies and we'll let them know like where are those locations exist, where all this plantation is there, but they have not geotagged it. So we help them pinpoint those locations probably which they could not have been able to using the ground team. So we help them identify locations where this plantation exists. Again, we also let them know like what is the expected yield, what is the expected height and age of the plantation. So we help them with multiple things. So this has been an ongoing activity. It's been there for more than 4 years now, and this is one such example. There are a lot of such plantation companies we are working with in Indonesia, Malaysia, Austria, Brazil. So you name it, like we are present there, and we are helping those big plantation companies. So coming to like some individual use case farmers, like there are a lot of farmers who are using the system on their own. Like they just download the application and just submit their farm coordinates, and they're good to go. So we have like thousands of such case studies wherein farmers are directly like receiving this data on their smartphones and their laptops, and based upon whatever the results have been so far, they take actions on the ground and they are able to like increase the overall yield, and overall they are able to save a lot of money because of it. So there are so many such cases. One such case is this farm called Viswa Matha Farms. They are totally into this concept of zero budget natural farming, wherein it's natural farming, but one step further ahead. Like they don't use anything, they use anything and everything which is there inside the farm, like nothing from outside the farm. Like all the fertilizers they generate from within the farm. They don't use anything from the out like from They don't use any other like third party like fertilizers. So they also have been using the system for almost 3 to 4 years now, and they again, because they're organic farmers, it for locations where organic farmers they don't get good yield, for them it was a big game changer because now they know in advance where or probably the situation is like pretty much critical, and then they accordingly because they have so much information to actually ensure that they not do not miss out upon any critical steps. They use this satellite data to actually ensure that they are getting the maximum output from their farm. So yeah, uh, I think I have covered most of the things. I would love to like answer any questions. Just a few things, and now I'll wrap it up. So this is the like this is an actual real uh, current farm map wherein these yellow dots are basically the locations where uh, the farms which are getting data from Farmonaut exist, and you can see that currently they are in like so many countries, and it's increasing day by day because our like presence is increasing pretty rapidly. And in this sector, being accurate, fast, reliable, and providing information in the language farmers understand, not everyone is doing. This is where we like are so different from any such other remote sensing and satellite based company, because we are very close to like understand and like work in the language which farmers understand. So that's what makes us different, and that's what makes our adoption pretty robust and advanced. And just to give you a context, we have been in the business for almost 5.5 years, and we have been profitable since the beginning. We have not faced any losses. Like it's a cash positive business, and we are not running on any venture funds. We are totally like driven by revenue. Like whatever revenue comes from our business, that's getting used to expand the business. So that's what we have done. We have uh, like so this is just I just wanted to like give you any context that despite like we that's what our like moat is like, because we are not we're totally driven by the customer itself. It gives us more strength. Like we can innovate, we can ideate, we can build features, build like generate things quickly, because now we actually think from the brain of the farmer. So that's it. So how do you get started? As mentioned, if you have to I have to reiterate again, just submit your farm. There are multiple ways. You can use our mobile applications, web application, use WhatsApp. If in case you're a startup or a company who has their own applications, you can use our API, and that's it. Just submit your farm. After that, within 5 minutes, you'll receive the first report, and every 3 to 5 days, you'll start receiving the results. Once you receive the results, just go and inspect the farm and accordingly take actions on the ground. As simple as that. And this is an iterative thing. Like can you are expected to do the same every 5 days when you receive a new report. We also provide data on a frequency of a daily basis, but not every farmer and every farm requires that frequency of data. But if it's needed, we do provide that data to our customers, but it's all on a case by case basis. We have a company in Indonesia who require data at a frequency of 10 minutes. So we are now actually going to provide that data on a 10-minute frequency. Like every 10 minutes, they will get to know what is happening in their larger geography. So that's a separate story, but these frequencies, these availabilities, these things all can be customized, because it's a system which is pretty flexible. So uh, the opportunities and possibilities are limitless. So I think that's it. I mean, I'd love to answer any questions which you probably have. Thank you.
Thank you, Ankur. That was a great presentation. It's really awesome the amount of agricultural data you get directly from the ground of your farmers. I think that's pretty cool. Does
Thank you.
anybody have any questions? Crickets
I'll
from.
start if you want. Barry, how accurate, like what resolution do you get on the satellites? You talked about like doing half-acre farms, et cetera. So are you coming down to the individual plant level? Is it within a meter square? What's your resolution?
So most of our data is coming at a resolution of 10 meters per pixel. and that converts into almost how much? Almost 20 pixels per half acre farm. So if you see over here, like these boxes, if you can see, this is basically 1 pixel. And this is 10 meter by 10 meter. Like for every 10 meter by 10 meter of area, we generate one single like piece of information. So compared to drones, definitely it's pretty less. But this is still pretty useful. Why? Why? Because if you know that there's something wrong in this 10 meter by 10 meter area, you're not supposed to go and visit the entire farm. Just need to focus on this particular part. We can also provide data at a even higher resolution. For example, I told you about this tree counting thing. So for tree counting, instead of using this 10-meter resolution data, we use data at a 40 centimeter resolution. So because the use case is different and precision and accuracy required is different, we change our data source over here. So we use resolution as small as low as 40 centimeters to as big as 10 meters. It all depends upon the use case. I hope I answered the question.
Yeah, thanks. I've got some follow-ups, but I'll wait for other people may have questions.
Sure.
Hi, it's Leah Weaver from Nofia. Can you hear me? Great.
Yeah, I can hear you. Yeah.
Yeah, I think just for the applications for kind of Northern Ontario farmers, a lot of the crops are much larger acreages and like of a lower value if we're going to have, oats and things like that across many acres. Is there a kind of way that you can structure, the subscription payment for folks that would have lower value crops across larger acre?
Definitely. I mean, based upon because farmers may have a different like acreage with them, so we provide a tier-based subscription model wherein you can start as low as like $30, wherein like within $30 you will be able to monitor up to 50 hectares of your farmland. And as the area increases, you can just keep on changing your like usage tier. So, for example, there are a lot of farmers in US, Canada, and Australia where the farm acreage is pretty big, and accordingly they keep on changing their like usage tier. Even if it's a low value crop, because the system itself is very cheap, it's it's gonna like really doesn't cost you much, and still you'll be able to like get more insights from it.
Okay. Yeah, I found the whole thing really fascinating. It's amazing to see how far things have come just in terms of this tracking to be able to do it with satellites. And how about do you identify that the people are property owners through this process, or could folks ask to track other people's fields or whole groups of fields? And how does that work?
So when a farmer is submitting their farm, they have to disclose like we don't encourage one person to be monitoring the farm of the another person. It always has to be some mutual understanding. But in our case, we have never faced any such issue. It's always the farmer or the someone who is managing that farm who monitor their data. In cases of businesses, definitely when we are engaging with businesses, we do have that understanding that whatever farms they are going to monitor with us, they already have got the consent of the farmer actually to monitor their farms via satellites. So in those cases, it's the businesses who ensure that all these paperwork and all these things they have already done with their own like customers. So we have not faced any such issues, but obviously we keep on like updating our terms. But yeah, that's a good question. Like usually it never happens like one user monitoring data of the other farmer. But
Yeah,
yeah,
I
I
would feel
mean,
like, yeah, not so much like a neighbor monitoring a neighbor, but as AI expands and monitoring expands, you would think that there might be opportunity for people in marketing and things like that to scan large areas for information,
definitely.
right?
Yes, yes,
Yeah,
definitely. Yeah.
it's fascinating. Thank you. That's great.
So one of my follow-up questions, Ankur, is so you're diagnosing your system is basically diagnosing problems, let's say, or looking what's there. How do you calibrate that, or do you get out in the ground and calibrate? So as Leo said, Northern Ontario has a soil map profile. Do you compare what you're saying against something like that, or do you get out and do some actual testing to check actually, how do you check that?
Yeah, it's a very good question actually, because ground truthing the data that is getting generated via our systems is a very important part. And because of physical limitations, see, since we cannot go visit each and every location in every country, so it is the farmers and the users who are using our data, they actually give us that feedback. So we have built those mechanisms within the applications itself that whatever data that we are generating, they can instantly provide us a feedback, like which of these insights did not match with their ground reality. And once they provide us with the data, if in case there is any very broader mismatch in the data that we provide and the ground reality on the farm, which is very rare, but any such incident occurs, we get that feedback from those customers, and we then again like retrain our models, fine tune the algorithms, and ensure that whatever such like deviations are coming, we are able to mitigate it. I can give you an example. Like for example, recently in Argentina, we're working with a lot of farmers. There has been a case wherein if you check the Buenos Aires area, you will find that like in case of potato, the average yield is around 70,000 hectare like kgs per hectare for an entire year. Like, however, like in our however, this particular farmer, they were getting twice the yield that than the normal average value. So once this mismatch happened, they actually shared with us the feedback, and then we again retrained our models and actually to ensure like because they're doing much better than the average farmer over there. Definitely, there's something that probably our system lagged to gauge that like better than average like performance of those farms. So whenever these such cases come, it is the customers who actually let us know that they have found these anomalies. Then we actually then go deeper into it and then use probably more historical data, because in our case we have access to data from 2017 and onwards of every location on Earth. So if in case we find such anomalies, we just focus on that geography, maybe like, go back maybe another year or two, and if in case we already know by the help of our customer like what has been the historical trend of yield forecast and other things, we can then use those as benchmarks to further fine tune the data. So this is just one case wherein this just happened very recently, almost a month back, and we used their feedback to further fine tune the results, because those are like very unexpected, extraordinary results that you don't see every day. So yeah, I mean, definitely, if I have to summarize it, sometimes there are issues when the results do not match with the ground data, and then we use the feedback from the customers to ensure that whatever parameters that were overlooked during those analysis, we like ensure maybe to give more weightage and maybe fine tune more like algorithms. With the advent of AI, now it has become more easier. Like we can just train our models at a faster rate. So it's an iterative thing, and we always encourage that the more and more feedback that we receive, it's easier to further better the model. I hope I have answered the question.
So then, and Rachel just cut me off if someone else's question, but so I get data from you and it shows me that I need more phosphorus for if I'm growing wheat, whatever, I need more phosphorus in this 10-meter section versus the next 10-meter section. I have a variable uh, application for fertilizer. Do you provide that data to interface with my monitor on my variable rate fertilizer applicator so that it automatically feeds in and adjusts the rate of application of fertilizer as I go up and down the field? Does the RTK technology we have in Northern Ontario work with that, or how do you do that?
Yes, that's one of the major part over here, because this integrating this data as a VRA map into these hardwares, we do have that compatibility. We can You can import this data and like use it in your hardware. It can be from anywhere, like whichever company you prefer the most, and it is like adoptable. Like it's doable. Like you just let us know what hardware you're using. We can help you import this data to your like hardware as VRA maps, and you can use that data to take actions on the ground. So yeah.
Okay.
So this quickly, like this is how the system looks like. I mean, you just log into the system and then you have multiple things. You can just get farm advisory like this. Like in this specific case, we can see that the entire farm is coded in purple. And if you see this purple is actually an indication of that this farm requires irrigation attention. Probably the crop health is okay, but this farm has some irrigation issues. And according that's why the system has given the proper irrigation schedule for the next 7 days. And so what we would encourage is like, because the system is free for trial, like if in case you want to explore more, we would encourage you to maybe submit some farms into the application, and whatever results are getting generated, and you can use that to actually like validate the accuracy as well. Like we would always encourage that. That will further like boost that confidence that this is not just like science fiction. It's actually matching with the ground reality. So we would encourage that. There are a lot of things you can do, like index results, there are reports, detailed reports. You can download and use it in your own computers or laptops. A lot of things are there. I think given the limited time that we have, I'll skip these. But yeah, a lot of things are there. If in case there's someone who is pretty technical, we have a proper developer documentation. These days, a lot of companies, because they have their own agricultural apps, they want to use this satellite interface on top of their applications. That's why we have this API. You can just, it's a pretty easy and like robust, comprehensive documentation. You can just connect our like system with your system using the API, and your all these insights that you receive from our apps you can use on your own applications as well. So a lot of companies have done that API integration. A lot of companies they do license our system as well, because sometimes they want to maintain their brand name. So we do white labeling our system. We have done this white labeling in multiple countries: Australia, Germany, Nigeria, Algeria, Indonesia, Austria, like you name it. The like multiple places we have done this. Yeah.
So when we're looking at that green value scale that you're able to track,
Mhm.
how close is that to a tissue test, like in its accuracy? And can you kind of talk about that science a little?
Definitely. Yeah, so let's take this farm for example in this particular use case. So we see that this is an NDVI image, which is normalized difference vegetation index. So NDVI images, they're sensitive to the percentage of chlorophyll content in your tree, in the leaves of your plants. So if you had higher chlorophyll content, higher photosynthetic activity in your plants, you will have higher values of these. So because it's directly assessing that specific uh, part of your plants, these results are very close to like the tissue thing that you mentioned. So if you get that testing done, you will find that there's very much similarity in the results that are getting captured using these sensors, and from the tissue results that you will do on the ground. Because it's at the end of the day measuring that same specific thing, but from space.
Yeah, absolutely. It's so fun to think about how much work goes into this on the ground and to be able to grab that information. Even if it's a 5-day lag, that's still how long it
Yeah.
takes to get samples back and things like that.
In a lot of cases, this 5-day lag in a lot of crops, in a lot of geographies, this 5-day lag is not a disadvantage because for them it's okay. But there are a lot of crops which change very rapidly, even on a daily basis. So for those specific use cases, we do provide data on a daily basis. But again, as the frequency increases, the cost to the farmer increases. So those advancements, they make more sense when you have a larger area to monitor, because then the cost upon you it averages out. So for example, this company which I mentioned about, this Godrej plantation company, because they have hundreds of thousands of acres of farmland with us, they very often go for high resolution, higher frequency data. So is the case with one of the other Indonesia-based company because they are planning to monitor 400,000 hectares of farmland. So for them, it's even making more sense to have even higher frequency, like because in their case, they want to monitor wildfires in their larger area. Like in Indonesia and Malaysia, or in oil palm, you face like heavy wildfires, and for them, being able to monitor like where all these wildfires are and able to like prevent them at a faster, it's very important for them. So for them, we are going to provide this data at a 10-minute frequency. Like whatever, if in case any fire occurred at this point of time, within 10 minutes, we'll let them know that the fire has occurred at that location. So just to sum it up, all the frequencies, all the wavelengths, all the temporal resolutions, resolutions exist. It's all upon like what makes sense to you in the commercial angle.
How big is your team?
Yeah. Again, so we are a very lean team. We are a small team of 20 people. And despite being a small team of 20 people, we are managing more than 200,000 farms. It's all because of the automation and all the robot systems that we have built. We don't need so much human workforce to actually manage such a big like user base. Since it's a technology company, it makes it easier for us.
Who are your biggest competitors in this field? Even if you're present in lots of other companies under different names, are there other people who are the bigger players or?
Definitely. I mean, there are a lot of companies in this market. You can Google them on your own. But like, because as I mentioned, that remote sensing and satellite is not something that we have invented. It has been there for decades in the market, and there are a lot of companies who are doing it on their own. There are a few companies. I mean, I will not take the names, but one of the major differences, for example, this company called Godrej, they were using data from one of the very big older names in the market. They have been in the business for more than 10 years now. And what is the challenge that they mainly faced from them was like their system was too scientific. Like if you want the satellite system to be adopted by the entire organization, your team requires to have some basic minimum understanding about various remote sensing indices and various report formats. So this is where they found it pretty challenging because they had to spend a lot of time to train their team in learning these new notations like these NDVI, EVA, SAVI, and they make it compulsory that you have to learn these indices, then only you can use the system. So because of it, they could not scale the that particular company's data in their organization because it was too complicated, and that's where we
Mhm.
came into picture. We actually made it easy for them. Like you don't need to worry about learning these indices. We'll provide you data in the language which you understand. For example, like even today in a lot of organizations which are pretty big, they still rely upon Excel sheets and documents, Google Docs to actually impart information within their teams. So no matter how much big, important, and useful you make your dashboard, you'll also have to have that minimum compatibility wherein you can't change the behavior of data consumption for a specific segment of users who are pretty rigid in the way they consume the data. So that's why we ensure that that does not end up being a limitation to us. We ensure that if they understand Excel sheet data, we will also provide this data in Excel sheet formats because they won't change their behavior. They have been there like using their behavior for multiple decades. So rather we make it flexible and make it easier in whatever way people find it easier to like adopt.
Okay. Very, very cool. Thank you.
All right, are there any more questions? I hear crickets from the floor. Okay, thank you very much, Ankur, for sharing all of that with us and for all of your time. So we recorded this, so we'll be sharing the recording as well with everybody who registered. So if anybody has any additional questions, then we'll get them in touch with you and your team. It's a great piece of software. I think saying it's a piece of software is downplaying it. It's very cool, and I is, yeah, very useful on farm. So that's fantastic. Thank you very
Thanks.
much. And everybody can have a great night.
Yeah.
Okay.
It was a pleasure for me too, like to share all this data. If in case if you have any questions which you forgot to answer, we forgot to answer for you. If you have any such things, we'd love to answer it even after the this presentation for sure.
Okay, awesome. Thank you so much. Have a great night.
Yeah. Thanks a lot. Good night. Have a great day. Bye bye.
Thanks.
Thanks,
Bye.
bye.